Just a quick reminder before we begin to put the date on the top of this question here, right before it says the radio audience. Kind of where I have it highlighted is where I suggest for you to do that. Just again, to keep yourself organized. We're going to do a lot of notes this year, so I think it helps. Okay, so let's look at this example here. And we've got 4 different types of tables. And I am going to, if you haven't read it already, first off, go ahead and read it. I'm going to specifically draw your attention to the word categories here. As this is categorical data, it's in categories. So the types of graphs we're going to talk about today only relate to categorical data, not to quantitative data. Okay, so just keep that in mind kind of throughout the video. 4 different tables. So this one says frequency table. This one says relative frequency table. We're going to talk about those in just a second. This one is a pie chart and a bar graph. Yeah, you should have seen those types of things before. It's all the same data. So it takes radio stations and it classifies them, and then we've got the classifications here. Okay. So let's look at kind of what's happening in these 2 tables here, the frequency table and the relative frequency table. You'll notice that all of the categories are the same, but they've got different numbers next to them. This one says count of stations. This one says percent of stations. So using our deductive reasoning, I'm going to guess that a frequency table talks about counts and a relative frequency table talks about percents. You might also notice down here under total, this one does not total up to 100%, and we will attribute that to round off error, which just means when you round them, since it's not the exact decimal, sometimes it doesn't add exactly to 100%. That's okay. It just happens. Some questions that you should start to ask yourself. What are the individuals? What's the variable, or what are the variables, plural? So kind of keep those in mind as we're going through the video today. Okay. Your first definition is for a frequency table. And the frequency table does exactly what we talked about earlier. It displays the counts of variables. Another word you'll hear used instead of counts is frequencies. This is just the number of stations that fall under these categories. So for example, 750 stations are Spanish language stations. Okay. Then we have a relative frequency table. So this tells you the relative frequency in terms of the total. So that's going to display the percent of each variable. The relative frequency is another word for percents that you'll hear. So for example, instead of saying that 750 programs are from the Spanish language, I could say that 5.4% of all the surveyed stations were related to the Spanish language. So it's just another way of saying things. Now here I've also mentioned for you, these are all useful to display categorical data. So what I am going to suggest to you, we write over here on the side for categorical. Help if I could spell categorical. Just so that you remember down in the future, because there's not really a good header here that tells us this is for categorical data. Okay, so let's look at some graphs. Oh, there are some really bad graphs out there. Let me tell you guys, statistics is just so easy to mess up. And there are so many bad graphs. This graph is from DirecTV, and it is not my favorite graph. When we are together, we will look at some bad graphs that relate to all sorts of things and things that I found on the news, just living my daily life, and you find a bad graph. So you'll start to do that too, don't worry. But we'll look at some more current examples when we get to see each other. So here's the graph, and you can see it on your paper there too. This is a real ad from DirecTV, and it's terrible. And my question to you is, what problems do you see? So take a minute and look at this graph, and don't think of it as an ad, because obviously this ad is going to steer in favor of DirecTV. It's an ad for DirecTV, so that's going to be its bias. So let's not worry about that. But just in terms of being a graph, what sort of issues do we have? Okay, there's 2 things that I've pointed out. The bin width and the scale. Bin width tells you how wide the graph is. So these 3 graphs all have separate bin widths. This one is the largest, and this one's the smallest. A good graph, they'll all be the same, okay? Because your eyes are naturally drawn to area, not to height. So by making this one longer, the area of this rectangle is so much bigger, and it makes the difference between DirecTV and Dish seem much greater than it is, when in reality DirecTV only has 14 more channels than Dish does. Okay. The other thing is the scale. So this right here is supposed to represent 14, and this right here is supposed to represent 81 minus 56, which is much larger than 14. And let me tell you, that doesn't look like the scale is really correct. So the two issues that I have with this graph are bin width and scale, again, because our eyes are drawn to area. Just naturally, just as human beings. And DirecTV knows that. That's why they made this graph like that. And I'm not talking about their marketing strategy. I'm strictly talking about why is this graph bad. Okay, basically, let's think about it. All ads you see are going to have graphs that are going to be skewed in the direction of whoever they're trying to promote. That's just the reality of it. Okay, so there's another graph on the next page. So let's look at the next page. Let me get myself organized here. As statisticians, your job is to notice things about data. It's all you're really supposed to do in your job. Notice things. Make conclusions, and the best way to make conclusions is by just looking at the data and seeing things that we notice. So what I want you to do is write something that you notice about this data. It doesn't have to be the most magical thing you ever come up with. And there's really not that much to look at here. So it's possible that all of us are going to come up with very similar ideas. But what I want you to do is in the answer box that's going to pop up in this part of the video, share your complete sentences about what you're noticing. And you can see what your classmates have written too. Yes, write complete sentences. Welcome to statistics. That's what we do. So, I want you to just notice something. Whatever it is that you notice about just this data there. Okay, we don't need to talk about the graphs yet. Let's just talk about the data. Okay, so here is a clever graph that uses pictures instead of numbers and instead of bars. Are you noticing anything about this graph? Are your eyes drawn to area as opposed to the height of the computers that are there? They should be, and that's something that's very misleading about this graph. So by using computers and enlarging the Mac computer, they've really misled the audience into thinking that Mac has sold a lot more. Don't get me wrong, Mac has sold a lot more. However, they've really accentuated it in this graph here. Okay, there's two possible bar graphs here. Take a minute, pause the video. One of them could be considered deceptive. I want you to decide which one. Did you notice that this scale starts at 10, whereas this one starts at 0, making this PC line look like basically 0, when it's really, it's not that, it's 12%. It's not like it's a big percent. However, now it's 2% by getting rid of that first 10%. Okay, so it's considered deceptive because it doesn't start at 0. So some takeaways from today. Just beware when there's pictures in a graph. And again, watch the scales. The bin width and the scales are very similar in how they deceive people. We're going to, again, like I said, look at some graphs that are deceiving in other ways. And so we'll talk about other ways we can deceive people. These are just a few examples here.